Hi, today we're going to learn about proportional equations and proportional graphs. So first we start with our bell work. Give an example of two proportional fractions. This might feel difficult, but really all we do is start with whatever fraction we want. How about like 7 over 12? Then we just choose any number to multiply by. We could choose to multiply by 100 if we want to, the top and the bottom. And then we'd end up with 700 over 12. 100. And there you go. Those two are proportional fractions because when you simplify 7 over 12, it is 7 over 12. And when you simplify 700 over 1200, it is 7 over 12. Awesome. Is this table proportional? If so, what is k? Remember, we have to do y divided by x. So this is a challenge question. We have to do 8 divided by 2, which is 4. 12 divided by 3, which is 4. 20 divided by 5, which is 4, and 28 divided by 7, which is 4. So yes, it is proportional. K equals 4, because that's the number we got every single time. And we could even write the equation y equals 4, because that's the number we got, with an x next to it. Okay, our goal today, well, there's a couple of goals. The first one is to identify proportional equations. Well, remember we just wrote an equation for the table, y equals 4x. If that table was proportional, then that means this equation is also proportional. So the rule is that the equation has to look like y equals some number, where that number is, k is the constant of proportionality, with an x next to it. So k is the constant of proportionality. Okay, so here's some examples. K equals 5. K equals -1/2. On this one, it doesn't look right. So we're like, oh, maybe it's not good. But actually, all you have to do is solve for y. Divide both sides by 2, and we get 5 over 2. And y is by itself, so k is 5 over 2. So all of these are proportional. Now, compared to these, this has something added or subtracted that makes it not proportional. Something subtracted, not proportional. Now this, it looks similar to what we just did before, solve for y, divide by 2, but I have to divide everything by 2, and I get y over, here's the same fraction as before, but something is added or subtracted, so it's not proportional. So, proportional and k is 4. Proportional and k is 4. Not proportional because something is added or subtracted. This one we need to solve for, we're not sure yet. So divide both sides by 3, and we get y equals 3x, which is proportional, and k is 3. Again, we got to solve for y, get y by itself, and we get y equals a fraction, 3 over 4x. Fractions are fine. But then we have plus 2 over 4, and we don't want anything added or subtracted, so that's no good. And let's check this last one. We have to get y by itself. So let's add 3x to both sides. That is so difficult to see right there. And now we have 6y equals 3x. Oh, divide both sides by 6, and we get y equals 1/2 x. So this is an example of yes, proportional, but it didn't look proportional in the beginning. So we had to do some work to solve. Okay, yes, proportional, and k is 2/3. We don't know yet, so let's divide both sides by 3. Y equals 2 over 3x, and look at that. It is proportional, and it's the same thing as before. 2 over 3 is k. All right, let's add x to both sides because we're trying to get y by itself. So now we have y equals x, and yes, it's proportional, but we don't see a number here for k. Well, that just means there's an invisible 1, so k equals 1. And here, same start, add x to both sides, and now we have y equals 5 plus x. Well, we don't like anything else with the x, unless it's being multiplied. I should say we don't like anything being added or subtracted with the x. So this one is not proportional, even though the first one was, yes, proportional, because 0 plus x is just x. Okay, so that was equations. Now let's look at graphs, proportional graphs. Graphs are proportional if they are linear. That's a vocabulary word that means straight line. and go through the origin. That's a vocabulary word for 0, 0 on a coordinate plane. For the point x comma y, so that means if we're on a graph and we have a coordinate point, maybe it's 3 comma 5 or whatever, then the fraction y over x is k, the constant of proportionality. Constant of proportionality. Also, in graphs, especially like word problems and such, the constant of proportionality when something is proportional, okay, that's important, but the constant of proportionality when something is proportional, that's the same as the unit rate. So like, oh, I bought 12 bananas. What's the price, for $18 for some reason. What's the price of one banana? Well, that's the constant of proportionality, and that's also the unit rate, whatever the price of one banana actually was in that weird example. Okay, so here's what a graph needs to look like. It has to have a straight line. It has to be a straight line, and it has to go through 0, 0. Remember, those are the two things we wrote down. It has to be linear and go through the origin, so it has to be a straight line and go through 0, 0. So yes, it's a straight line. Yes, it goes through 0, 0. This one shows dots on it. They don't always show dots on them. It's nice when they do, but they don't always. So then we can choose any of these points. We can choose any of these points. So here's 1, 3 or 2, 6. And remember back here it said for this point we do the y value on top, the x value on the bottom, and that is k. So for this point, the y value is on top, the x value is on the bottom, and that equals 3. Let's check the other point. The y value is on top, the x value is on the bottom, and that also equals 3, which means that yes, it's proportional because we got the same number both times. And the constant of proportionality is 3, and we could write the equation y equals 3x. Again, it's a straight line through 0, 0. We have this point, 1 over 4. That's as simplified as it gets, 1 over 4. How about this next point, 2 over 8? Well, it simplifies to 1 over 4, so yes, we got the same thing, so yes, it is proportional, and yes, the equation is y equals 1/4 x. This one, not proportional. It's not a straight line, it's not through 0, 0. Some other bad examples might be, that might trick you, like that could look like a straight line, but it doesn't go through 0, 0. Or something like this, it goes through 0, 0, but it's not a straight line. Those could trick you, but they're not proportional. Okay, so yes, proportional because it's a straight line through 0, 0. Not proportional because it's not through 0, 0. Yes, it's a straight line through 0, 0. Now let's go back and find the constant of proportionality and the equation. So notice how these don't have the dots. So we can find where does this line cross the coordinate plane nicely. Here we've got 2 over 1. Here we've got 4 over 2. And here we have 6 over 3. All of those simplify to 2, so our equation is y equals 2x. This one, it didn't work, so we don't have to solve it. Okay, let's look for nice points. Here's a nice point, like where the line crosses the coordinate plane, the grid of the coordinate plane. Okay, so that'd be 2 over 3. This would be 4 over 6, which does simplify to 2 over 3. So our equation would be y equals 2 over 3x. Okay, draw an example of a graph that is proportional, something like this, to the best of your ability to draw a straight line. Write an equation that is proportional, y equals 3x. Anything, like any number, as long as you just put a number here and nothing else weird, you're good. And our exit ticket. Is this graph proportional? Yes, it's a straight line through 0, 0. If so, what's the equation? This has some points marked for us. So we could do 10 over 2, we could do 15 over 3, there we go, 20 over 4, whatever it is, 5 over 1, it should equal 5. So the equation is y equals 5x. There you go, that is proportional equations and graphs. You got this.